Okay, a distant galaxy has a redshift of 30 nanometers, which normally would have a frequency of this many hertz. How fast is the galaxy traveling away from us? Remember the equation. Start step 1, delta F over F is equal to V over VW. And so what I want to do is I want to now figure out what the answers are. Okay, now I have a redshift of 30 nanometers. Now we have a bit of a problem here. This is in hertz, and this is in nanometers. One is a wavelength and one is a frequency, and this is frequency, right? And so what I need to do with this is I've got to convert my 30 nanometers into hertz. Now if you remember, a nanometer, I'll put it up here so that you see, a nanometer is a billionth of a meter. So if you remember, we can say that frequency, I'll say frequency is F, is equal to C over the wavelength. So C, of course, if you recall, is 3 times 10 to the 8th meters per second, divided by, and I'll say 30 times 10 to the minus 9th, because that's a ninth is a billionth, 10 to the minus 9th meters. I have to put that in meters, so my meters cancel. So my hertz, now I'm going to get in my calculator here, and I'm going to clear it, I guess. So I'm going to say 3 second function E 8 divided by 30 second function E negative 9, and I get I get 1 times 10 to the 16th hertz. That's my change. Okay? So now, what is my change in frequency? This is this many hertz. So I'm going to say 1 times 10 to the 16th divided by my frequency, which is this 4.3 number, 4.3 times 10 to the 14th. And that's going to equal to V. Now V is what I'm trying to find. V is my variable, and the VW is the speed of the wave, and since this is light, it'll be the speed of light, which is 3 times 10 to the 8th. Now, again, we're going to cross multiply, right? So if I cross multiply, I'm going to say 1 times 10 to the 16th, parentheses, times 3 times 10 to the 8th, parentheses, is equal to 4.3 times 10 to the 14th times V. All right, so what does this multiply out to? So I'm going to get my calculator going here. So I'm going to say 1 second function E 16 times 3 second function E 8 equals. I'm going to get a big Herkin number. I get 3 times 10 to the 24th is equal to 4.3 times 10 to the 14th times V. Now I'm running out of space here, but you divide both sides by this 4.3 number right here. And so I'm going to take that 3.2 number, which is right over here on my calculator, and I'm going to divide that by 4.3 second function E 14 equals. And I get a really big number, which doesn't totally surprise me because this is how fast a galaxy is moving away from us. I'm going to just, by the way, there's a cool thing. I'm not sure how to show this. I don't remember on this calculator. I'm just going to write that in scientific notation. I'm going to say I said about 7.0 times 10 to the, now let's look, 1, 2, 3, 4, 5, 6, 7, 8, times 10 to the 9th meters per second. So that galaxy is moving away from us at about 7.0 times 10 to the 9th meters per second. So yeah, it's actually kind of a remnant of the Big Bang in the fact that there's an expanding universe. So typically we see things having a redshift, which helps us understand the expanding universe, which we'll talk about when we talk more about galaxies. But this is how they figured all that stuff out. Make sense? Okay, so I think we're about done. Actually, we should just briefly talk about one more thing here. Not really. Yeah, this is just another picture. I'm not sure it makes a big difference. So that's all. That is the Doppler shift. I guess that previous slide, it does talk us about how, like a guy with a radar gun who's trying to catch you if you're speeding in your car or whatever, they use the concept of the Doppler shift to figure out how fast you're going. So it's kind of the same concept. But the key thing is to understand kind of these two pictures and the definitions of the Doppler shift. Probably the notes you're going to have here are going to have lots of pictures. and then of course the mathematical equations. Make sure on the mathematical equations that you're spending some time going through your calculator the same time as I do, so that you can understand which buttons to push. It gets kind of confusing with that double E button, and a lot of students kind of mess that up, and so I don't want you to make that same mistake. So that's all for today. We're going to move on. We're almost done with chapter 3, and after chapter 3 we get to learn about telescopes. That'll be fun, won't it? All right, we'll see you in class. Bye.